Hey folks, it's Speedistevie video time again. Here's a video from NASA about the Mars mission. Less than a day after NASA's Mars 2020 Perseverance rover successfully landed on the surface of Mars, engineers and scientists at the agency's Jet Propulsion Laboratory in Southern California were hard at work, awaiting the next transmissions from Perseverance. First up, it's an animated landing video of how Perseverance will have descended down to the surface of Mars. As data gradually came in, relayed by several spacecraft orbiting the Red Planet, the Perseverance team were relieved to see the rover's health reports, which showed everything appeared to be working as expected. Adding to the excitement was a high-resolution image taken during the rover's landing. While NASA's Mars Curiosity rover sent back a stop-motion movie of its descent, Perseverance's cameras are intended to capture video of its touchdown, and this new still image was taken from that footage, which is still being relayed to Earth and processed. Next, there are some actual color images received from Perseverance after it had landed. Finally, there's video material from NASA, which has some great 4K footage of Perseverance's sampling system and of the rover itself.
We are working on something that is the cleanest we've ever really attempted to send into space.
The Perseverance mission has as its central goal astrobiology and also being the first step in Mars sample return. We're going to collect a suite of samples, about 35 samples, that each weigh about 15 grams.
And the reason we collect those intact samples is that we are the first mission that's part of Mars sample return, and it's our job to collect the samples intact to be brought back to Earth for further analysis.
To better assess the question of, was there life previously on Mars? Inside the belly of the rover sit a number of sample tubes and an entire adaptive caching assembly that is used to help collect these samples.
Extraordinarily complex robotic system. And to make it even more complicated, it has to be super clean. We don't want to have these samples come back from Mars and discover life in them, but then realize, oh, that's life that was in the apparatus when we sent it to Mars.
That was a big challenge for the mission because we were meeting cleanliness standards that no rover mission has ever had to meet before.
The requirements that we have for this mission are extraordinarily challenging.
Once we would go through machining the tube itself, getting all of our protective coatings on there, and then looking at our beautiful tubes, we found carbon contamination in places we were not expecting. So as a team, we all had to really come together and look at the entire manufacturing process, how we're handling these tubes. We had to start polishing the interior bore prior to putting on some of our protective coatings.
It meant having to come up with an entirely new technique to clean all of the hardware and demonstrate that the hardware could maintain that cleanliness all the way to Mars.
That's what JPL does. I mean, we discover problems and then we solve them.
Having these very strict controls and this record of how much contamination or how clean these tubes are prior to going to Mars is essential for that return sample science.
Great discoveries require remarkable evidence, and so the cleanliness of the sample tubes and of all of the hardware that's going to be collecting those samples is paramount in making sure that the evidence and that the story and that the discoveries that come from these samples that are brought back are irrefutably Martian.
That's it for another Speedistevie video. Subscribe now.